Hello students, this is Neha Mathur and today in this video we are going to discuss classification of signals in detail. In my last video I told you about the brief introduction about the classification of signal, in which I told you about discrete and continuous time signals with their 5 subcategories. So before starting the topic, consider to subscribe my channel and click on bell icon to get updated for the upcoming videos. Fine. So we are going to start classification of signal. As I told you in the last video that a discrete time signal or a continuous time signal may be a deterministic or random, may be a even or odd, may be a periodic or aperiodic, may be a power or energy, or casual or non-casual. So firstly I am discussing the first category, which is deterministic and random signal. See, both the terms are opposite to each other, so their definition will also be opposite. If a signal comes under a category of deterministic signal, as the name indicating deterministic, which simple means that signal will have no uncertainty with their amplitude and phase with respect to time, which simple means that the signal will have regular pattern. Such type of signal will never shows uncertainty, as well as which has regular pattern. That type of signal comes under a category of deterministic signal. The best example of deterministic signal is a sine wave, a simple sine wave. This signal has regular pattern, as well as there is no uncertainty of its amplitude and phase with respect to time. So thus such kind of signals comes under a category of deterministic. There are several other examples of deterministic signal. It may be a exponential signal like this or like this. So these all signals comes under a category of deterministic signal. While what about the random signal? Opposite to the deterministic signal, random signal has uncertainty with its amplitude and phase with respect to time. As the name indicating random, which means it has irregular pattern. You cannot define its pattern in terms of amplitude with respect to time. Just an example, thermal noise. Or I can say my pitch when I am delivering my lecture to you. Sometimes it has a high pitch, sometimes it has a low. It depends on the way of delivering the lecture. Similarly, thermal noise, it is definitely uncertain. So it may be like, so such kind of signals come under a category of random signal. This is the first category. The one more thing, any continuous time signal, any discrete time signal may be discrete or random. This is about the first classification of signals. Now come with the next category. The second category is periodic and aperiodic signal. As the name indicating, again, periodic and aperiodic, opposite to each other. If a signal is repeating itself at a particular interval of time, at a particular period of time, such signals come under a category of periodic signal. While if a signal has irregular pattern, if a signal is not repeating itself after a particular period of time, or I can say that if a signal has a no particular time duration for their repetition, such signals come under a category of aperiodic signal. Just an example, if I am drawing the example of a periodic signal, it's like simple. Again, I am taking now I am taking a square wave. See, a square wave. Here you can say that this wave is starting from this point, and this is a unique representation of a signal after this particular time duration. The signal is repeating itself. Such signals come under a category of periodic signal, in which a particular signal repeats itself after a particular period of time. While in an aperiodic signal, a signal may be like this, in which you do not have a particular time period for the repetition of that signal, or with reference to that, this square wave, I can draw it like this. This is a first unique pattern. This unique pattern is not repeating. If this unique pattern is not repeating after a fixed period of time, this signal comes under a category of aperiodic signal. Fine. So this is about the periodic and aperiodic signal. Now come with the third classification. Now the third category is energy and power signal. To define the energy and power signal, you will have to calculate the value of energy and power for that particular signal. After getting the proper value of energy and power from that signal, then only you can define that it comes under a category of energy and power. But you must have a proper base, you must have an idea about the category for their categorization. Simply, if the energy of that signal is finite and power is 0, then such signal comes under a category of energy signal. So if any signal is a energy signal in this, if any signal is an energy signal, in that situation the calculation of the energy for that signal will provide you finite value, where the power will be 0 for that particular signal. While if I am talking about the power signal, it will be completely opposite. For the power signal, the value of the power will be finite and the value of the energy will be 0. You must have idea about this consideration. After that, you will have to calculate the value of energy and power for that particular given signal. One value will be finite and there will be 0. So on the basis of that, you can define that it comes under the category of which signal. Fine. The next category is casual and non-casual. A simple classification of the signal is a casual and non-casual signal. You will have no need to calculate any parameter. Simply you will have a signal, and if the value of that signal is 0 for t less than 0, then this signal comes under a category of a casual signal. This is if the signal comes from continuous time signal. If it belongs from a discrete signal, then the representation will be like this. As I told you in the last video, that for continuous time representation will take t, while for discrete time representation will take n. So if a signal belongs from casual signal category, then it will be like this, that for the t less than 0, for the n less than 0, the signal will be 0. And if the signal comes from non-casual signals category, in that situation xt will be 0, but when t will be greater than 0. Similarly, for discrete time signal, if xn is equals to 0, then only xn is equals to 0 for n greater than 0, then only the signal comes under a category of non-casual signal. While fine, so any continuous signal, continuous xt, continuous time signal may be casual or non-casual, depends on the time. If it is 0 for t less than 0, then it will come under casual category, and if it is 0 for t greater than 0, it comes under non-casual category. Similarly, it is defined for discrete time signal. Fine. And the last category for the signals classification is even and odd signal. Okay, so if a signal is even or a signal is odd, you will have to determine that categorization of the signal on the basis of one simple calculation, and the calculation is xt is given to you. Xt means a simple signal, and you will have to calculate x of minus t, which means in your given signal you will have to replace that t from minus t. Now you have two signals. The first signal is x of t, which will be given to you, and the second you will have to find x of minus t. After that, if that x of t is equals to x of minus t, that means there is no difference from x of t and x of minus t. Both are representing, there is no difference for the representation of the signal for x of t and x of minus t. That means that particular signal comes under a category of even signal. But if that x of t is equals to minus x of minus t, that means you are getting reverse signal when you are replacing t from minus t. In this situation, that particular signal comes under a category of odd signal. Okay, so what is the conclusion? In a simple way, I can define that you will have to give an x of t and you will have to calculate x of minus t. If your given x of t is equals to your calculated x of minus t, then it will be even signal. And if your given x of t is equals to minus of x of minus t, minus x of t, this comes under the category of odd signal. This is for the continuous time signal. If it is discrete time signal, then simply t is replaced by n. Simple. Fine. So I am again repeating that your any signal, if the signal is x of t or x of n, it may be a periodic or aperiodic. Periodic means if that particular signal is repeating itself after a particular time interval, or aperiodic means not repeating itself. May be a deterministic or non-deterministic. Deterministic means having a regular pattern, having no uncertainty, while random means random, simply the signal is going to be uncertain with amplitude and time, phase with respect to time. The third category is casual and non-casual. Casual means the given signal is equals to 0 for t less than 0, and if that given signal is equals to 0 for t greater than 0, it will come under a category of non-casual signal. The next is even and odd signal. So if a signal is providing the similar value after reversing the time representation, that it comes under a category of even, while if it is not same after the reversing of the time, it comes under a category of odd signal. And the last one was energy and power signal. For that you will have to calculate energy and power as well. If energy is finite and power is 0, then it comes under a category of energy signal, while if power is finite and energy is 0, it comes under a category of power signal. This is all about the classification of all the signal, a signal which may be a continuous time signal or a discrete time signal, because I am defining my signal, I am representing my signal with time domain only. This class, this and the last class in which I told you the brief introduction of the classification, and today I told you about the detailed classification of the signal when we have a signal with time domain representation on the representation only. For the frequency domain representation we will definitely discuss, but later on after this time domain representation. So this is all about the classification of the signal. Hope you are following my content. If you are following, consider to subscribe my channel and click on bell icon to get updated for the upcoming video. Also click on like button. Okay, fine. Thank you.